Hello students, welcome to Surface Chemistry Part 7. Let us begin this part by understanding the concept called mechanism of Michelet formation. Let us try to understand the mechanism of Michelet formation and let us understand this concept with the help of examples. Let us take soap and let us dissolve. You know already in lower classes you people studied soaps are sodium or potassium salts of long chain fatty acids, and they can be represented by the general formula of RCO minus Na plus. The best known example is sodium stearate with the formula of CH3 CH2 16 times COO minus Na plus. And it can also represented with the help of this formula. Here you can see that this is our C hydrocarbon part, this is hydrocarbon part, and this is the functional group of carboxylate ion. So in soaps we have mainly two parts. One is this hydrocarbon part and another one is this functional group carboxylate part. When we dissolve the soap in water, students, it dissociates and forms carboxylate ion, RCOO minus ion, and Na plus that enters into the solution. This carboxylate anion, once again, it has two parts. The first part is long chain hydrocarbon part, that is hydrophobic in nature. Hydro means water, phobic means hating. That means it is repelled by the water, whereas we have polar carboxylate anion part that is attracted by the water molecule, and hence it is hydrophilic in nature. So let us see that one by one. So when soap is dissolved in water, it dissociates into carboxylate ion, RCO minus anion, and Na plus ions. The Na plus ions thus formed that goes into the solution. The RCO minus ions, however, as I already told, it has a two parts, students. Let us see one by one. The first one is a long hydrocarbon chain indicated by symbol R, that indicates alkyl group, and polar group, that is CO minus, that is carboxylate anion. So this hydrocarbon part is hydrophobic in nature, that means water repelling. Hydro means water, phobic means repelling. And it is also called as a non-polar tail, whereas this polar carboxylate ion is hydrophilic in nature, that means water loving, and it is a polar ionic head. It is called by polar head or ionic head. So this is the long hydrocarbon chain that is called hydrophobic tail, insoluble in water, where this is the polar carboxylate anion part that is attracted by the water, hence it is called hydrophilic head. It is generally represented as follows. Hydrocarbon part indicated with the help of zigzag lines, whereas hydrophilic head is indicated in the form of spherical. Now let us see what happens when the soap is dissolved in water. When soap is dissolved in water, students, the carboxylate ions, thus whatever formed, they are present on the surface with their CO minus groups in water, whereas hydrocarbon chains are staying away from this polar carboxylate ion groups. Let us understand this concept with the help of example. And one important point is, whatever this Michelet formation takes place, students, that takes place only on above critical Michelet concentration. So once we reach the critical Michelet concentration, the anions, that is nothing but carboxylate ions, they are pulled into the bulk of the solution and they aggregate to form spherical shape. With their hydrocarbon chains, they are pointing towards the center of the sphere. Okay, where CO minus groups, they remaining outward. So this diagram clearly helps you to understand this concept. When concentration of soap increases above Michelet concentration, this carboxylate anions, they start aggregating and they lead to the formation of spherical shape. With this carboxylate anions, they are pointing away from the sphere, that means away from the center of the sphere, whereas hydrocarbon part is pointing towards the center of the sphere. So like this mesolle formation takes place. So once that mesolle formation takes place, students, that helps in the cleaning of the cloth. Now let us see cleansing action of soaps. See, here we have grease present on the surface of the cloth. Soap molecules for mesolle, we know that soap molecules for mesolle above critical mesolle concentration, and even this mesolle formation also takes place around the oil droplet in such a way that hydrophobic part of the ions that is going to dip in this grease present on the cloth. Why? The question arises because this grease is also organic in nature. So organic compound dissolves in organic. So that theory is going to be applied here, that is applicable here. Hence what happens, this hydrophobic part, whatever present in the case of soap, students, that is going to mix up with this grease. Whereas this hydrophilic that stays away from this. Here you can see hydrophilic part projects out of the grease droplet like this. See students, hydrocarbon part that is dissolves in grease, whereas hydrophilic part that stays away from the grease. Stearate ions arranging around the grease droplet like this, they are going to be arranged. Once this arrangement takes place, this grease droplet is going to be surrounded by this mesolle. And once we apply the pressure, once we rub it, so what happens? Running water is going to carry this grease. The surface tension between the cloth and the grease is going to decrease, and running water is going to carry out this one, removing out this grease dirt from the cloth. The oil droplet surrounded by the stearate ions is now pulled in water and removed from the dirty surface. Now let us see preparation of colloidal soles, very important from examination point of view. Generally they ask this question for 2 marks. We have 2 types, one is by disintegration method and another one is by aggregation method. See, as the name itself indicates, students, disintegration indicates it is breaking of the larger substances into colloidal particles, where aggregation, as the name itself indicates, it is aggregation, association of small molecules or even atoms thereby to form the particle that has a size equal to colloidal particles. So as I told, this involves the breaking down the bigger particles into colloidal particles, and this is done by the following methods. The first one is electro disintegration method, that is also called Briggs electric arc method. This method is also called as Briggs electric arc method. So electro disintegration means by applying electric current we are going to break the substance, thereby we are going to get the particle of size equal to colloids. And the second one is peptidization. What is that? Let us see that one also. Okay, so out of these two, let us see the first one, important one, that is electro disintegration, or also called Briggs electric arc method. This method generally used for the preparation of metal soles, students, like gold, platinum, silver, etc. So we can prepare gold, silver, platinum, etc. Purple of Cassius, a colloidal solution of gold, is obtained by this method. So let us understand this Briggs electric arc method, how they are going to prepare gold sole or a platinum sole or silver sole by using this method. Now students, let us see Briggs electric arc method. The instrument used in this method, students, consists of 2 electrodes dipped in cold water bath as shown in the diagram. Here you can see It consists of two metal electrodes. This is one metal electrode. This is another metal electrode that is dipped in a cold water bath. So this water beaker or a container kept in a bigger water bath that contains surrounded with ice pieces as shown in the diagram. So here we have two metal electrodes. You can take, if you want to prepare gold soul, then you can take gold electrodes. If you want to prepare platinum, then you can take platinum electrodes. So it is kept in ice cubes or surrounded by ice cubes. See, this method involves passing electric current through the electrodes made of desired metals like gold or platinum, as I already told. The metal is suspended in a trough of water and that is cooled by the surrounding ice as shown in the diagram. Students, what happens when I pass electric current, very high voltage electric current when I pass? Here you can see there is a formation of electric arc or a spark is going to be produced, and this metal is immensely heated and it vaporizes. This metal is immensely heated and it vaporizes. Okay, as that vapor tries to escape through this solution into the atmosphere, what happens? This solution is surrounded with ice cubes. Am I correct? So automatically it is cooled and it is get condensed, thereby forming metal colloidal particles. So let us see that once again. When we pass electric current, due to intense heat, the electric spark or arc is going to produce. So automatically that metal changes into vapor state, but since it is cooled from the surroundings, it is condensed, thereby to form the colloidal particles. Now let us see the next method that is used for the preparation, that is peptidization. Very important method. They ask this method for 2 marks. See, peptidization involves the conversion of freshly prepared precipitate into colloidal particles by shaking it with suitable electrolyte. The added electrolyte is also called as a peptidizing agent. Students, what is peptidization? It is a conversion of freshly prepared precipitate into what? Colloidal sol or colloidal particle. How? By shaking it or mixing with it with suitable electrolyte. And whatever suitable electrolyte we use here is called as peptidizing agent. Let us see example. The freshly prepared precipitate of ferric hydroxide is treated with the ferric chloride, students, and it is stirred well. The ferric hydroxide thus surrounded by the Fe3 plus ions and thereby formation of a positively charged colloidal sol particles. And one more example, when freshly prepared silver iodide is shaken with the silver nitrate solution, once again we get the positively charged colloidal sol. That silver iodide is surrounded by the Ag plus ions and we are going to get colloidal particles. So examples also important, definition is also important. They ask for 2 marks. Now let us see preparation of colloidal sols. In that one we have seen disintegration methods. Now let us see aggregation methods. So as name itself indicates, as I already told, this involves the joining together of small molecules in a large number and thereby formation of the colloidal particles. And this can be done by the following chemical methods. Let us see one by one. The first one is a double decomposition method. So in double decomposition method, so there is a exchange of ions takes place between two substances that we are going to mix. Here oxygen is exchanged with sulfur and thereby forming the colloidal sol. Arsenic sulfide is going to form and it is prepared by using this method. Second method is by reduction. In this method, metals like silver, gold are reduced to form respective metal sols. For example, gold chloride is reduced with the stannous chloride to form gold soul. Third method is by oxidation, by using suitable oxidizing agent. Here sulfur is prepared by this oxidation method. Oxidation means addition of oxygen or removal of hydrogen. Here hydrogen reacts with bromine to form hydrogen bromide, thereby forming sulfur colloidal soul. The last one is by hydrolysis method. So in hydrolysis method, especially metal chlorides are converted to colloidal soul. Ferric chloride on hydrolysis forms ferric hydroxide as colloidal soul. Thank you, students.